Partial decomposition. Suppose we have 1 over 4 plus 2 over 3 equals 11 over 12. Then we can rewrite 11 over 12 as the sum of 1 over 4 and 2 over 3. Similarly, 1 over x minus 3 minus 1 over x plus 1 can be rewritten as 4 over x minus 3 times x plus 1. Then we can rewrite this fraction using two simpler rational expression. The objective is to find the antiderivative of a rational expression, and if we can factor the denominators and rewrite the expression using two or more simpler rational expressions, we then find the antiderivative of each of these rational expressions easily using either the natural log or use substitution or some other methods. The method of rewriting the rational expression using simpler rational expressions is called the method of partial fractions or partial decomposition. If f of x equals p of x over q of x, where p and q are polynomials, then this rational expression is called proper if the degree in the numerator is less than the degree in the denominator. It is called improper if the degree in the numerator is greater than or equals the degree in the denominator. If the rational expression is improper, we first must perform long division. If it is proper, and the denominator is a product of distinct linear factors, then we can decompose it with the constant coefficient in the numerator for each of these linear factors. If there's a linear factor that repeated twice, then we would set up two rational terms for the repeated factor, increasing the exponent each time. The exponent tells us how many terms are needed. For example, 2x squared plus 1 over x plus 1 times x minus 2 cubed equals a over x plus 1 plus b over x minus 2 plus c over x minus 2 squared plus d over x minus 2 cubed. There are three factors of x minus 2. We would need three rational terms with x minus 2 in the denominators. Each time we increase the power of x minus 2 by 1. Notice that there are four factors in the denominator. We then need four rational terms when we decompose this rational expression. If the rational expression is proper and there is one irreducible quadratic factor in the denominator, then we would use a linear expression in the numerator for the irreducible quadratic. Thus, the degree that we use in the numerator in the partial fraction is one less than the degree in the denominator. The degree of the constant a is 0. The degree of the linear factor x minus a is 1. The degree of the irreducible quadratic x squared plus bx plus c is 2. The degree of bx plus c is 1. Note also that if we use the capital letter A already, then we need to use other capital letters than A because there's no guarantee that we would end up with the same coefficient. Similar to the repeated linear factors, if we have repeated quadratic factor that is irreducible, we would have to use as many rational expression for the irreducible factor. In this case, the irreducible quadratic x squared plus bx plus c is being repeated twice. We would then need two rational terms for the denominator x squared plus bx plus c, and we increase the power by 1 each time. the numerator for the irreducible quadratic is still linear, thus bx plus c and dx plus f. For example, to decompose 3x squared plus 5x minus 2 over x plus 1 cubed times the quantity x squared plus x plus 1 squared. We first noted that this is proper because the degree in the numerator is 2 and the degree in the denominator is 3 plus 4, which is 7. The linear factor x plus 1 is repeated 3 times, and the irreducible quadratic x squared plus x plus 1 is repeated 2 times. Remember, the exponent of the factor tells us how many rational terms we need to set up for the corresponding repeated factors. Thus, this is being decomposed as a over x plus 1 plus b over x plus 1, increase the exponent by 1, plus c over x plus 1 cubed, 3 terms for x plus 1, plus we move on to the irreducible quadratic factor. The numerator must be linear, but we used the letters capital A, B, C already. Thus, the linear factor is now dx plus e, plus this irreducible factor is being repeated 2 times. We need one more rational term for x squared plus x plus 1, but we increase the power by 1. The numerator is still a linear expression, which is now fx plus g. We can use any letters that we haven't used before. There's nothing special about these letters. For example, find the decomposition of 2x plus 1 over x squared minus 5x plus 6. First, we see that this is proper and the denominator is a quadratic, but it is reducible. We can factor x squared minus 5x plus 6 as x minus 2 times x minus 3. Thus, this is the product of linear factors, and the linear factors in the denominators are distinct. We first set up the partial decomposition by writing a over the linear factor x minus 2 plus b over x minus 3. Notice that there are 2 factors in the denominator. We would need 2 rational terms. The next objective is to find the coefficient a and b. We observe that if we were to combine the 2 factors, then the least common denominator is x minus 2, x minus 3, with a times x minus 3 plus b times x minus 2 in the numerator. This fraction must be the same as 2x plus 1 over x squared minus 5x plus 6. For these 2 rational expressions to be the same, the numerator must be the same. The 2x plus 1 must be the same as ax minus 3a plus bx minus 2b. That is, the coefficient in front of x on the left-hand side must be the same as the coefficients in front of x on the right-hand side. The constant term 1 on the left-hand side needs to be the same as the constant terms on the right-hand side. This is a system of linear equations. We can use either substitution or elimination methods to find a and b. Let's use the elimination methods. 5 equals minus a. Thus, a equals minus 5. And if a equals minus 5 and 2 equals a plus b, then b needs to be 7. Thus, the partial decomposition for this rational expression is minus 5 over x minus 2 plus b is 7 over x minus 3. How do we know that this works? We can check this by finding the least common denominator of the two rational expressions. Negative 5 times x minus 3 plus 7 times x minus 2. The least common denominator is x squared minus 5x plus 6, because this is how we factored x minus 2 and x minus 3. Negative 5 times x is negative 5x, minus 5 times negative 3 is plus 15, plus 7x minus 14. Minus 5x plus 7x is positive 2x, 15 minus 14 is 1. Thus, this is the correct partial decomposition.